As we discussed earlier, we are going to focus on Word2Vec. For Word2Vec, we have two different algorithms, primary algorithms, better to say. One is SkipGram, other one is continuous bag of word or CBOW. SkipGram, SkipGram and CBOW. Before I start describing the functionality of those two models, there are three very important terms which we need to be familiar. First one is target word. Target word are the word which currently the center of our analysis, you can say. Alright, so for example, our target word may be known. Okay, normally those are notated as WT, T for target words. What happens for every document or every text sentence, we start our analysis from the very first word itself. We consider our first word as target word, and then we move our target words to the next word, and so on, so on, so on, so on. We move till the end of our documents or whatever we have for our processing. So literally every word in our corpus will get a chance to become a target word. Another term, target word, is the word which is currently center of our attractions, you can say, or center of our analysis. There is second term that is called window size. Window size. Window size is a numeric values or integer sort of things. It may be 2, 3, 4, 5, 10, 20, 30, 40 or some numbers. What it means, for example, let's consider here the window size is 2. Okay, I'm just picking one number 2 here. Window size is 2 means we are going to consider 2 words in the left side of our target word and 2 words in the right side of our target word. Okay, so window size 2 means we are going to focus on these 2 words also and these 2 words also. Window size is that's only. So suppose if we have window size of 4, we are going to consider 4 words after this target word. 1, 2, 3, 4. We are going to consider all these 4 words and all 2 words, available 2 words in the left hand side. So there is some concept called padding. We are going to pad unknown characters in the words in the left hand side. So that would be a bit complex, so we can discuss it later. But for now, what you can take, window size is the size of the window we are going to consider both the sides of our target word. Next word is context word. Okay. Context words are those words which are falling within the window size of the target word. Okay, you got it right. In this particular case, window size is 2, our target word is known, and so our context word would be a word shall do. All 4 of them are our context word. Okay, so I'm coming back once again. Target word is the word which is currently at the center of our analysis or our training or maybe anything. Window size, or the size of the window we are going to consider left side and right side of our target word. Context word are the words which are present in the left side or in the right side of our target word. Okay, in this particular case, known, we have no is the target word we have randomly picked up. Window size we have picked up randomly 2. So context word is a word shall you. Okay, this way we will shift our target word to the right side or left side, whatever directions you need to go, and our window size and context word, window size will be same and context word will be changed accordingly. Now I am coming back to our two favorite models. Okay, here SkipGram. In this particular SkipGram model, the purpose of SkipGram model is that you are going to have target word, known target word. That means we are going to give target word to this model, and the model needs to predict the context word. That means we are going to say to our model that known is the target word. You tell me what are the context word of the target word known. So the model will return a word you shall. So in SkipGram model, you are going to pass the target word as input, and the model is going to give you the output as context word. So for example, T to C. I don't know how to write it down, but target you have, you are going to predict context. In continuous bag of word CBOW model, it is just reverse. So you are going to give the context words, multiple words together, and you need to predict the target word. So here alright, so if we give the example, if we try to explore it in this example, in CBOW model, you are going to pass a word shall you. So the model is going to say, okay, your target word supposed to be known. Okay, this is the whole purpose. And one important thing here, that the sequence of these context word normally doesn't matter in most of the basic models, and later you can add some other complications to consider the sequence as well as one of the parameter. But in these two basic models, or in our basic approach, we are not going to bother about the sequence of the output. Like our SkipGram is saying word shall you a. This may be the sequence, but it's supposed to say all these 4 words at the end. So we got to few very important things here. First, the sentence itself, you shall know a word by the company it keeps. We should always keep this thing in mind, that we can recognize its sentence, but meaning of a particular word from the kind of company it keeps. That means from the context word it has. Target word, normally we consider the word which is at the center of our analysis at this point of time. So that is normally noted as WT, and context words are normally noted as WT minus 1 to WT plus 1 plus 2. Okay. T is basically the current word, minus 1 plus 1 on the left hand side and the right hand side of our sentence or list of words. Alright, so this section is pretty much done. Now we are going to jump into the model, Word2Vec model. Okay, how it works and what is the architecture of the model, and we are going to go through that process, and then we can do a quick recap to understand whether we have clear understanding about this end-to-end neural natural language processing framework before we jump into our coding section. Okay, next sections we are going to discuss about the Word2Vec neural network model. Okay.